A few months ago, I posted a video on a vintage Philco IF alignment generator, and I restored it so that in the future we could do alignments on the older 25 megahertz sets, television sets and radios. Well, my friend Al, Mr. Tubes, found the companion Philco signal tracer, and it's supposed to be in this box. So I want to get it out. He always packs things very interesting. He's a veteran TV repairman who has a really good memory on all the details of the different chassis and stuff. Let's get it open, and I want to recap it because I want to use it. Want to get it working. So let's see how this is packed. It should be interesting. Integrated circuits is packing peanuts. I wonder what this is. Zenith integrated circuit 221-40 ECG 707. Isn't this one of those color demodulator ICs? Isn't that what this is? That they use in the 14 tube hybrid sets. That's a good thing to have. Ooh, Funai. Well, that thing's, oh, it's a double. Were people really changing these ICs in televisions? Wow, man. I guess today, in today's age of throw it away and buy a new one, it's made in a dark factory. This seems impractical. Look at this, Orion. Orion and Funai. Nothing but the best. Funai. NEC. Okay. Yeah, we literally have integrated circuits as packing peanuts. What do we got here? Horizontal output transistor. 2SD 1426. Someone can look that up. Post 500 comments on what it is. Okay, let's see what we got here. Okay, this is a very special type of color tube, and Al set this all up, and we're going to do a video on this. It's a viewfinder, but it's not a conventional CRT, so we're going to save this for a future video. This is some very special thing that uses infrared something, so we're going to set that aside. We have more integrated circuits as packing peanuts. Look at this. Wow, this thing's heavy. Let me lift it out. Okay. Tube in the probe, Philco 7030. This is the one we got right here. Tube in the probe. So it's like some of the old VTVMs. But, you know, it's going to need to be recapped. All right. Ooh, the finest cabinetry. Look at that nice modern remote. Solid state integrated circuitry. So this must have been in the 70s. In 1954, RCA Victor was your first choice for color TV. Today, 14 years later. So this is like an RCA. Oh yeah, this is when they started to get tacky in the 70s. Well, no, 54 plus 14. We're not quite there yet, but they were starting to get cheesy here. This is when they started to get the plastic wood and the particle board. Think of how many of these things, how many millions of these things they must have made. They're still easy to find today. Ooh, tabletops. $589 for a tabletop. $439. That would be thousands of dollars in today's money. Anyway, this is not about... Let's see what we got here. Radio Electronics Magazine. Radio Electronics Magazine. Build the Lawn Ranger. Does anybody want to build a Lawn Ranger? How to build a CD player. Ooh, solid state hobby circuits, man. Ooh, I'm going to be right into that. Let's see. Radio electronics. Well, I've never seen a pack of wipes used as padding material, but it looks like that's what we have here. And here it is. So if you watch the video on the alignment generator, it's got the same handle, it has the same finish, it has the same thing where the probe goes in the side. So this is going to be very cool, and I'm assuming like the alignment generator, this is going to need it's going to need capacitors. We can open it up, we'll open it up, but we need to restore it. I want to take a look at this hobby book real quick. Let's destroy the video with this. Just open it up to a random page. Here we go. It's a phono amp. Magnetic phono input. And then over here we have output. So, of course, this has to have a ton of gain to it. Is this a key for doing HF Morse code key? Oh yeah, a lot of these type of things were in the Forrest Mims books that were, well, not quite this complicated. Wonder if this is scanned. Maybe this has a date with the PDF machine. Okay, so here it is. Here's the probe. It's not in like super ultra mega good condition, but you know what? We want to use it. It's not going to be a shelf queen. And there's a vacuum tube in here and a light. This is rock hard. This is a no-go. I mean, for testing, it's probably okay, but not for use. Let's open it. Check this out. This is like a sensitivity adjustment. It's got 1, 2, 3, M, Anyway, I got it apart and got some capacitors here. These need to be changed. That goes to the output. Got a bodged in electrolytic here. Someone didn't use an iron that was hot enough. This thing is so old it uses a field coil speaker. That's impressive. 3 tubes, and I believe there's a tube in the tip. Power transformer. It's got 2 electrolytics there. I kind of want to recap the whole thing. Don't need test equipment that's burning up and not working. I love the across the line filter right here. That's the line cord. That's pretty cool. I would like, this is not connected to anything, huh? Is that connected to something? I don't think so. I would like to power it up just to make sure the speaker is good. But I don't want to destroy anything, but since it does have a new cap in it, let's just go for it. Speaker sounds like it's rattling. That's kind of crappy. Oh, what is this? This is a signal tracer. It's used to follow the flow of RF through a radio mostly, to look for, you know, what stage is dead in the radio. Good old octal sockets. Yeah, it sounds like the voice coil's broken in that. Well, okay, I just changed my strategy here. I think I'm going to do the wax capacitors and test the electrolytics. If the electrolytics are okay, I might just leave them. They're cold. Let me think about my plan of attack on this. I wanted to fully recap it, but if the speaker's no good and the light, I didn't even see the light working in here. Not that I need that. It was just kind of cool. Well, here's a picture of what's inside the probe. You can see it's got a tube in there. It's got a bunch of mica capacitors. How do you get it apart? $52.50 in the 1940s. And this is a schematic of just your typical All-American 5 radio converter IF, the detector and the audio output, and it's showing here These are basically instructions on how to use it to, you know, isolate where the fault is in the circuit. Here's the circuit of the actual thing. You see the probe here. I want the exploring lamp to work. Replace it with a bright white LED. Wouldn't that be cool? So those are the different modes right there. There's the tube that's in the probe. It's like the detector amplifier. So we just have two amplifiers, right? We have a 7L7 and a 7A5. So this thing should have a lot of gain. And then a rectifier and the speaker. How do you disassemble the damn probe? The detector tube and exploring lamp are contained in the... Access to them may be had by pushing in a small latch pin at the rear end of the probe and adding oil. What? Is the latch pin under this solder blob? Well, it certainly was. Let's see what's inside this. That's actually spring-loaded. How very nice. I was thinking it's a roll pin. There it is. There's the light bulb right there. This tube doesn't look like it's in the best shape, does it? It looks like that getter is very small. But this is super cool. And there's the bulb. Man, this thing has some hours on it. A GE51. I should have one of those around here. I don't know why they had that redundant ground wire on there. I don't understand the reasoning for that when it's grounded right there. Yeah, that bulb is awfully silvery. Here is an LED replacement, but I don't think this is going to work because this really wants the light going forward, and this is more for a dial light, but I'll try it. I mean, it kind of works, but it doesn't fit because it's too long. And I wonder if that LED is going to create noise in that probe. Because, you know, that LED is like half waving something. That it's not... I better go with an incandescent bulb. Yeah, I got a newish GE51. This is pretty cool how when you slide it into the case, this spring pushes... crimps the light bulb socket and it comes on. That is very cool. You know, they just used to build stuff to be built and be serviceable. Today it would be like a surface mount LED that you couldn't change. You'd have to replace the whole display. So there we go. I don't hear any hum, so I think the filters might be okay. Okay, I'm going to recap the wax capacitors. Checking some of the capacitors here. This one, we have 28 volts. And I believe we're supposed to have 50. I believe that's this capacitor right here. Then on the other side we have a 1/2 volt, which is, there's a little leakage, but not bad. Okay, so for the B plus we have 251 volts. They call for 245. And then on the other side of the field coil filter we have 207. 207 volts on a 160 volt capacitor. Well, that one should be formed up real well. Anybody see a problem there? And we should have 195. So yeah, we might want to get rid of that electrolytic, that 160 volt electrolytic that's got 200 volts on it. It's a little bit high. This one here that's isolation to the output is real leaky, 106 volts on the output. I wonder if the reason why this voltage is low is because this electrolytic right here is pulling that down. We might want to get that out of there because that's being fed by a 100K resistor. So any leakage there is going to pull that voltage down. So let's see if that's correct. This is the 100K resistor, and then this goes up to the 470. So we got 100 volts there. I'm just going to snip this damn thing. Ooh, sparky, sparky. Okay. Let's see. Can I not cut this? Come on. This is making me look like an idiot here. Come on, snippy, snippy. There we go. Wow, look at that. It went up to 180 volts. Okay, I'm going to connect the capacitor again. That's how leaky that electrolytic is. So we got basically B plus coming up through. That's the 100K. That's the leaky capacitor. That's the 470. That'll give us a lot more voltage on our probe. Hear the difference? Oh, this thing's going to be so damn sensitive. So I need to do some electrolytics here. This one needs to come out, and I need. Let me see what I got. I need 222 at 400 or something like that. Got some 22 at 400 volt capacitors. And I got some 0.01 at 630 volts, 103. So I'm going to get this out of here. I'd rather solder to there. Hopefully those will fit in here. I can squeeze those in. And that absolutely just pulled off of there when I... Wonder what they tried to use, acid core solder. Is that why that's all eaten up like that? Acid core solder. Or is that just like a grip of rosin? Anyway, they didn't use a hot enough iron. I'm gonna try and go through here. Here's the capacitor I changed right here. This is the one that was leaky, but I'm checking the rest of them. So they're all like 10 or 15 microfarads. So this one right here is measuring 20 at 23 ohms. So that one's pretty dead. The new one is measuring 21 at 3.9 ohms. And this is the other one right here. This one's measuring 2 microfarads at 783 ohms. And the other section... These are the two main filters. This is the main filter. And this is the one that had the low voltage, the 160 volt connected to it. And this one's measuring 2.6 microfarads at 700 ohms. So this one is totally trashed. I need to replace this one. And I should probably cut those out of circuit. Yeah, like see this one, I cut this one out of circuit. This is a low voltage filter. Sanching. Can we see that? Can we get in there? Sanching. Anyway, recap is complete of the electrolytics. I ended up using 2 of those because I have a board that's full of them. They're 22 at 400 Nichicon. So I used 2 of those for the 2 main filters. I used this one for that filter to the tube in the probe, and I just paralleled the Sang-Ching into the low voltage cathode bypass. So they're all cut out of circuit. You can see I cut the leads off. You know, it's not pretty, it's not as nice as what I like to do if I'm doing something for someone else, but since this is going to be mine, it's going to be occasionally used, and it's not going to leave my possession. It's all good. I changed this. This is the grid coupling capacitor from the preamp to the audio amp. I'm going to change the one on top, and then I'm done. Okay, well, we didn't quite get up to the 50 volts that the schematic says on the probe tube, but we're a lot closer than we were, so I'll have to take that. Let's see about our leakage here. We got 131 here, which is really kind of high, and we got 0 there. That's good. So it's kind of weird. Got 181 there now. We got 1.5 there. That's on that bypass tube. That's actually right. So our voltages look good now, except the voltage here is too high. Which either those resistors went down or the tube is bad. So this voltage here is really high. So either this resistor went down in value, or this tube is weak, or that resistor has gone out of spec, or that, no, because this is right. This is at 1.6. This is a little bit low, but I don't know. It's working really good. It's super, super sensitive now. I mean, if I just get my fingers within a centimeter of that, hear that? That thing is so sensitive now. I can't wait to try it out. Well, no wonder they had that other wire soldered onto that little peg. I pulled on the ground lead and it's broken inside. It just pulled right out, so I got to fix that. Sort of reading this. Look at this. The gain is 10,000. Signals tell the story all the way, picked off circuits from the antenna, all the aerial coil, all the way to the speaker voice coil. This thing is extra sensitive. Let's do a little demonstration here. This is a Soviet radio that I need to diagnose. It has, well, let me try and demonstrate the problem. Between stations, it's totally quiet, like there's a bias issue.
The government needs to open.
See how it just goes totally quiet? So you'll never get DX on it. So there should be noise between, you know, it's...
My priority is focusing on the needs and the devastation, frankly, that more than 300,000 Virginians are facing, and that's just the federal employees.
So see how that's distorted? Let's probe around here and see what we can find. Okay, so this is an example. This area right here is the audio amp. So if we listen to what I'm assuming is the beginning of the audio amp, then if we listen to the output, so it sounds good going if those are the audio output transistors right there, it sounds good going into them, but coming out, it's all distorted and clipped and sounds like they're unbiased. Here's another example. That's going in. This is coming out. So it sounds like, that's what the speaker sounds like, all distorted. So I think it's in the output stage. Anyway, you can use this to follow your way through the IF. I don't know where the IF is on this thing, but you can use it to follow your way through the IF and find, where the signal's lost. We'll use this a lot. I use a signal tracer a lot on radios. Well, there it is. Sort of restoration of a high-hour Philco 7030 signal tracer, and we will use this a lot while diagnosing radios. Transistor radios, tube radios, TVs, probably. Nice addition to the collection.